Alright, in today's video we're going to talk all about fractions, what they are and what can we actually do with them. So to start off, fractions are all about dividing things. So for example, let's say we've got a nice beautiful cake that's perfectly circular, and let's pretend I can draw better than I can. We have a beautiful little cake or a pie or a crepe, a stack of pancakes, something delicious. And we want to know how we can split it up amongst a group of people. So let's say we start slicing it in half, and then in half again, and then we start slicing them into other halves, and we want to split these up. Now, in this example, we have 1, 2, 3, 4, 5, 6, 7, 8 slices. Now, I'm not very good at drawing, so the slices aren't the same size, but when we're doing math with fractions, we're going to assume that each one of these slices is the exact same size. So when we're looking at a fraction, we've got a number on the bottom, which tells us how many times we've cut something. So in our case, it's a beautiful circular food that we've managed to cut into 8 different slices. The top number will tell us how many slices we have. So for example, if I ate 2 slices, then I have 2 slices out of a total of 8. So the bottom number tells you how we cut. So in this case, we cut it 8 times. And then the 2, or the number on top, tells us how many we want. So the bottom number 8 is how we cut it. We cut it into 8 slices. The top number is how many we want. We ate 2 slices, so that's 2 total. Pretty straightforward. And it doesn't just apply to food. I just really love to eat and I love food, so that's just the way it is for this one. Now, the question is, what can we actually do with this? Now, the same way that we can add, subtract, multiply, divide numbers, we can do the same thing with fractions. But fractions are a little bit weird in that multiplication and division is actually quite a bit simpler than addition and subtraction compared to regular numbers. So we're going to start off with multiplication and then division. So for multiplication, let's start off with a relatively simple fraction. We're going to have 1 over 2. So remember, the bottom number tells us how many, so there's 2 slices total. And the 1 tells us that we only have the 1 slice. And we're going to keep our numbers pretty small. So the second fraction is just 3 out of 4. So there's 4 slices, of which we have 3. Now for multiplication, it's actually really easy. You just go straight across. So it's just going to be 1 times 3 divided by 2 times 4. So 1 times 3 is just 3. 2 times 4 is 8. And look at that. We have 3/8. So multiplication, you literally just go straight across. Easy peasy. Now for division, things get a little bit trickier, but not too bad. So let's have a 1 over 2 times a, sorry, not times, we already did that. We're going to do a division by 3 over 4, which is going to look like 1/2 divided by 3/4. Now, I like math, and I will fully admit that this looks pretty gross. You've got a little fraction up top, a fraction down below, and you're dividing them. What the heck's going on here? Well, there's a simple little trick to division, which is you rewrite the top fraction. So you just literally rewrite it. So 1 over 2 is 1 over 2. And then the bottom fraction, we actually flip. So the 3's on top, which means that the 3 is now on the bottom. The 4 is on the bottom, which means it's now on top. So the 3 over 4 now becomes 4 over 3. Now what do? Well, this is where things get really nice. What we actually do is we now multiply. So basically a division is a multiplication with one extra step. All you have to do is flip the bottom one around, and then it just turns into a regular multiplication of fractions. So you're going to have 1 times 4 on the top, and then we're going to have 2 times 3 at the bottom, and we're going to have a 4 out of, well, 1 times 4 is 4, and 2 times 3 is 6. And look at that, we've got ourselves a 4 out of 6. So not too shabby. Now let's say that we were doing a multiplication or a division by a whole number. So we'll redo the multiplication because that one's a little bit easier. So let's say we have a 1 over 2 times 3. Now what the heck's going on here? Now we've got a fraction being multiplied by a non-fraction, which looks a little weird. So what are we doing here? Well, the trick is that we can actually turn regular numbers into fractions very easily by doing something that doesn't actually change anything at all, which is dividing by 1. So if I take a 3 and I divide it by 1, it stays a 3. So it seems a little silly that we're doing this weird division by 1 because dividing by 1 doesn't do anything. But what it does is it transforms the whole number 3 into a fraction, a 3 over 1. And then once again, we've got 1 times 3 at the top, divided by a 2 times 1. And we've got ourselves a 3, we've got ourselves a 2, and that's our answer right there. 1 times 3 is 3, 2 times 1 is 2. And that's how we can do a multiplication with a fraction and a non-fraction. We can do the same thing with a division. So if we had, for example, 2 divided by 1/3, what do? Well, the 2 is the non-fraction. Remember, we can always turn non-fractions into fractions by dividing by 1. So we're going to have a 2 divided by 1 being divided by a 1 over 3, which is going to look like 2 over 1 divided by 1 over 3. And remember, the division is basically just a multiplication with one extra step. So we rewrite the first one, which is just 2 over 1, and then we multiply by the bottom one flipped. So in this case, the 3 is at the bottom of the fraction. Now it's at the top of the fraction. The 1 is at the top of the fraction, so now it's at the bottom of the fraction. And then we have 2 times 3 at the top, which is 6. We've got 1 times 1 in the bottom, which is just 1. And we end up getting a whole number as a solution, which is just 6. So with these couple of examples, we can see that multiplication is the easiest thing to do because you literally just go straight across the top and straight across the bottom. Division is a little bit trickier because you have to rewrite the bottom fraction upside down, but then after that, it just turns into a straight multiplication across the top and a straight multiplication along the bottom. And if you ever run into a situation where you've got fractions and non-fractions, you can always turn a non-fraction into a fraction by dividing by 1. Because remember, divisions by 1 don't actually do anything, but even though they don't do anything, they can still be useful. And that's something that pops up a lot in math. In this video and later videos, we'll see how multiplying by 1 and dividing by 1 can actually be really helpful. So now we're going to move on to the trickier version of working with fractions, which is addition and subtraction. All right, now when things start to get a little bit complicated is when we start doing addition and subtraction. Now, adding and subtracting is the easiest thing to do with whole numbers, but with fractions, things get a little bit trickier. So let's start off with a quick little drawing to show why that is the case. So let's say that we've got 2 cakes. Again, imagine perfect circles because I cannot draw. And then this cake is sliced in half, and this cake is sliced into 3. And what we want to do is we want to eat one slice of cake number 1 and a second slice of cake number 2. So we're going to have one slice out of a total of 2 slices, plus 1 slice out of a total of 3 slices. Now the difficulty comes in with how do we compare the slice from cake number 1 from the slice from cake number 2? because obviously the slice from cake number 1 is quite a bit bigger than the slice from cake number 2. So what's going on here? Well, what's going on is that the bottom numbers do not match. And because the bottom numbers do not match, we're going to have a really hard time talking about how to combine two different sized slices. So earlier in the video, I talked about how we can multiply and divide by the number 1. And even though it doesn't actually do anything, it can still prove helpful. In this case, we're going to be doing the exact same thing. And the goal is to try and make the two bottom numbers look the same. Because if we can get the two bottom numbers to look the same, then we can talk about equal size slices. Now there's a couple different ways to do it, but we're going to start off with the easiest way, the way that always works. So we're going to start off with 1 over 2 plus, and I'm going to change the color of the second fraction for a reason that's going to be obvious in a little bit. Now, we want to make the two bottom numbers match. So what I'm going to do is I'm going to multiply the first fraction by the number 1. Except I'm going to write the number 1 a little bit differently. All right? I'm going to write the number 1 as being 3 divided by 3. And I'm going to multiply. Now, the reason I can get away with doing this is because 3 divided by 3 is just the number 1, and I can multiply by 1 without changing anything at all. And then the 1 over 3, I'm going to multiply by the number 1, but this time it's going to look like 2 divided by 2. So what's that going to do? Well, remember the fractions from before, where we have multiplication. We're going to have a 3 times 1, which is 3. We're going to have a 3 times 2, which is 6. And then finally, we're going to have a 1 times 2, which is 2, and a 3 times 2, which is 6. And we still have a plus in the middle. And look at that. Right now we have bottom fraction, same number, and as long as the number at the bottom is the same, we've got equally sized slices. So that means we can actually just straight up add. We've got 3 slices plus 2 slices. But the total number of slices at the bottom stays the same. So we've got ourselves a 5 out of 6 total slices. All right, so this last example, we were able to make the two bottom numbers of different fractions match one another. Because when you're adding or subtracting, we want to be adding equally sized slices together. Now, you might be wondering, well, how did I know that I should have multiplied the first fraction by 3 out of 3 and the second fraction by 2 out of 2? And the answer is, I know my multiplication tables. So I know that 3 times 2 is 6, and I know that that's the lowest common denominator that these two numbers are going to share. So the question becomes, what do we do if maybe A, we're maybe not that good at times tables yet, B, we're in a high stress situation like a test where our times tables are leading to nonstop brain farts, or C, we have a really weird looking fraction. Like for example, if we had something like 52 out of 117 plus 36 out of 48. Well, I'm pretty good at math and I'm pretty good at my times tables, but I have no idea how in the world we're going to make 117 look like a multiple of 48, or how we're going to make 48 a multiple of 117. So what do we do? Like, we're stuck here. Like, I want these two bottom numbers to match, and they're just not matching. And they're also really funky numbers. Well, there's a nice little algorithm that we can actually use. It doesn't always give us the simplest form of a fraction, but it does always work. And then if you get a non-simplified fraction, we can always just simplify after the fact with full confidence that our answer is right, even if it's not in the simplest form possible. So let's get to cross multiplication. Cross multiplication sounds like it's a multiplication because it involves multiplication, but it's actually a fancy way of adding and subtracting fractions that aren't immediately obvious. So let's give ourselves an example. So we're going to have 3 out of 5 plus 2 out of 4. What the heck is that going to equal? Well, if you're pretty good at times tables, you'll probably be able to figure out how to make the 5 and the 4 look like each other. But let's pretend we don't. Let's pretend we're really stressed, it's a test, brain fart time. Happens to the best of us. So cross multiplication is a way to always get the right answer. So what we're going to do is we're going to take the bottom number and then multiply by the top number. So we're going to have 3 times 4. Then we're going to take the other bottom number and multiply by the top of the other fraction. So in this case, we're going to have 5 times 2. And then finally, we're going to take the bottom fraction and multiply straight across. So we're going to have 5 times 4. Now, these two fractions are being added together, which means that we're going to have an addition in the middle. So whatever the sign is in the middle, it stays the same. So for example, if it had been a negative sign, then in this case, it would have been a negative sign. So if we're subtracting the fractions, we're still subtracting the fractions, but if we're adding the fractions, we're still adding the fractions. So you literally just rewrite that little operator in the middle. And then what that's going to give us is 3 times 4, which is 12, 5 times 2, which is 10, with a plus in the middle. And then we're going to divide by 5 times 4, which is 20. And in this case, we're going to have 12 plus 10, which is 22 out of 20. Now, 22 out of 20 is a correct answer, but it's not the most simple version of this fraction. And we can tell that immediately because we've got an even number on top of, on top of another even number. So because they're both even, I know that they can both be divided by 2. So what ends up happening is if I divide the top number by 2 and the bottom number by 2, I'm going to get 11 out of 10. Now, 11 out of 10 is as simple as it's going to get because 11 is a prime number, and a prime number is a number that can only be divided by 1 and itself, which means that I can't simplify it any further. And that right there is our most simple answer right there. Now, if some of you are feeling pretty proud of yourselves for knowing how to do this set of fractions without cross multiplication, then go ahead, pat yourselves on the back. It's definitely sweet that you know your multiplications tables and your brain's in a place where it doesn't brain fart and you can do this. So in this example, we could have done the exact same thing as we did in the previous example. So we've got 3 out of 5 plus 2 out of 4. Now, 3 out of 5, I know that I can make the 5 look like a 20 by multiplying by 4 out of 4. And I know that I can make the 4 look like a 5 by multiplying by 5 out of 5. And then we would have 4 times 3, because remember with the fractions we just go straight across with the multiplication. 4 times 5 plus 2 times 5 divided by 4 times 5. We're going to have 12 out of 20 plus 10 out of 20. So you can see right here that this is still just going to be 22 out of 20. So look at that. We have the exact same answer with 2 different techniques, which means that they're actually the same as one another. So the cross multiplication just lets you get away with maybe not knowing how to multiply the two fractions by the number 1 in such a way to make the bottom numbers match. You can just follow the little arrows. Each arrow is a multiplication. And then you've got your 3 times 4, your 5 times 2, and then at the bottom your 5 times 4. And just like that, we've got ourselves cross multiplication. So even if you've got a really funky number, we can still make it work as long as you remember the little pattern, which after a little bit of practice will be pretty easy to handle. All right, so there's one last topic that we have to cover before we can start doing our fun bonus extra problems. And that is that sometimes we have whole numbers and fractions at the same time. So let's go back to our little perfectly circular drawings of cakes. And let's say we cut the slices, we sliced the cake into 4 equal parts. And let's say I'm feeling very hungry and or this cake was very delicious. So I ate an entire cake and a slice of a second cake. So how do we actually talk about what's going on here? Well, usually we'll see something that looks kind of like 1 and 1/4. So the number 1 here corresponds to I ate an entire cake because I'm a big fat fatty boombalatti. And then the 1/4 slice refers to how much I managed to dig in to that second cake. I only ate a part of that second cake, unlike that first cake, which I just demolished. So the question becomes, how do we actually start to combine these? Because so far, all of the operations that we've seen, addition, well, division, multiplication, all that fun stuff, relied on us having one fraction, whereas here we've got a whole number and a fraction. Well, what we do is we turn the whole number into a fraction. That's what we're going to do. So in our case, we've sliced everything into 4s. So I'm going to do 4 out of 4 times the number 1, because I've got one whole thing out of 4 slices. And then we're going to add the 1/4 slice from the second cake. So that means that the number 1 is now a 4 out of 4 plus 1/4. And now we just do like we always do, add the numbers across the top. 4 plus 1 is 5. And then the bottom number, when you're doing addition or subtraction, stays the same because we're talking about the size of the slices here. So these are slices of size 4 or quarters. Now this works even if the numbers are a little different. Like let's say I ate 4 cakes and then 3 out of 4 of that 5th cake. Well, again, we're still talking about a 4, and we're still talking about quarters. So that bottom number is still a 4. So that means that I'm going to do 4 out of 4, because remember, I can always multiply by the number 1 because it doesn't do anything, even though it is helpful, times the 4 slices. So not the 4 slices, times the 4 whole cakes that I ate. So 4 over 1. And then this 3/4 here, how much I ate of that 5th cake. So that's going to equal 4 times 4, 16. 4 times 1, that is 4. And if we want to check our work halfway through, we can see that 16 divided by 4 is indeed that regular 4. So these two expressions are the same. And I ate 3/4 of that 5th cake. And we've got ourselves 16 plus 3, which is 19. And then again, we're talking about slices of size 4. So we're talking out of slices of size 4. So we've got 19 out of 4, which is the same thing as saying I had 4 whole things and 3/4 of the 5th unit. So these two are the same thing. Now, 19 out of 4 is a really easy way to figure out addition, subtractions, multiplications, and divisions, whereas 4 and 3/4 is a really easy way to visualize what we're actually talking about. So they both have their place. For example, 4 3/4 would be really useful if you were baking a cake, because you know, okay, I need 4 whole cups of flour and then 3/4 on top. Whereas if I told you I need 19 fourths of a cup of flour for this cake, most of us would go, what the heck are you talking about? So there's a place for both. So one's not necessarily better than the other. It's useful to know how to go from one to the other. And from there, we can actually start to do a whole bunch of fun stuff. Now that brings me to our extra fun bonus extra problems. All right, as always, we have our extra fun bonus problems to practice all of the techniques that we looked and learned at this video. We've got multiplication, we've got divisions, we've got combinations of whole numbers with fractions, and should be able to do all of these. I'll give you a second to hit pause so you can try and do them on your own, and then I'll write down the correct answers so that you can check your answers with my answers. All right, so I've written the answers in purple underneath the fractions. You'll notice that some of these answers have multiple equality signs, and that's because I'm simply trying to get to the simplest fraction possible. So the first one will be the result of cross multiplication, and then we just go simplifying from there, because a lot of times we're interested in the simplest form of the fraction. Not just because it's easier to work with, but sometimes because that's what our teachers have asked us to do. And a happy teacher is a happy grader, and a happy grader is generally a good thing to have on your side. That's it for us today, and I hope that you guys enjoyed working with fractions and you feel more confident working with them in the future.